first world problems.
The only places I know are like off the so.
All right, so one last idea before we do the review. Let me just ask you guys something kind of silly. How would you solve this problem?
Divide.
Divide by 3.
That's amazing. Why divide by 3? Because it's the opposite of multiply by 3. Bless you. So how would you solve this problem?
Square root.
Yeah, you square it.
Yeah, what's the opposite of multiply by 3? Divided by 3, so that's what you do. What's the opposite of square rooting?
Do the
Square.
Yeah.
I love it.
Yeah.
So that's
x
what
would
you
be
do.
25.
Yeah, you square. And x equals 25. Kick ass. Is it true? Is the square root of 25 5? Yeah, you can check it like you always would.
Is this 10.6?
So what did I do that was insane? Is everybody cool with that? What happened? It's the same thing we've always done. How do I solve for x? Undo all the shit that's happening to it. So I apply all the opposite operations. So what's the opposite of square rooting something? Squaring something. So here, these kill each other. And over there, I get 25.
So it's just multiplication pretty much.
What? It's squaring, which is based on multiplication, yeah. So, I mean, how would you do this one?
Do it there.
Yeah. What's the opposite of cube rooting something? Cubing it. So these kill each other, so you get x equals, what's negative 1 cubed?
-1.
Negative 1. So what's really funny is this is nothing new. This is how you always solve equations. Always. You just undo what's being done. We just had to talk about radicals until we felt comfortable. Now, like, if they show up in an equation, just kill them. Like always. Get them. All right, so what about this one here? Square root of 2 minus 3x equals 3.
You're going to square it?
Yeah. Yeah. Makes good sense. My variable is stuck in there, so if I square both sides, it gets freed up. Bam. So then what do I get here?
2 minus 3x.
I always feel bad for the person that somehow the square still is there and they foil that thing out. That square is dead. Okay, it's all dead. So 2 minus 3x equals
9.
9. Subtract 2, divide by negative 3, right? Subtract 2, divide by negative 3, get negative 7/3 eventually. Is that cool? Why is it okay that it's negative?
Because it's getting squared.
No, it ain't getting squared. Let's check it. Here's the original problem, right? The original problem ain't got no squares in it. So if I plug negative 7/3 in, that would be 2 minus 3 times negative 7/3. Is that equal to 3? The negatives cancel, and so do the 3's. Square root of 2 plus 7, is that 3? Is the square root of 2 plus 7? Yes, so it checks. It's fine that x is negative because it doesn't make the inside of the root negative. So don't just throw it out because it came out negative. You got to check to see if it makes the inside negative. Are you guys okay with that?
And if it does make the inside negative, it's...
Then you throw it out. It's what's called an extraneous root. Extra. Let me show you where an extraneous root comes from. That does sound like a dental procedure. We're going to have to extraneous root. No! All right. So if I had square root of 5x minus 1 equals negative 2, why would I hope to God that most of you would do no work on this and just write the answer? What's the answer?
A negative.
No.
Oh.
Well, I mean, that's something to notice, but what's the answer then? Can this happen? This says the square root of something is -2. Can that happen?
No.
So what's the solution?
No.
No solution. I love it. But let's do it anyway. Now, I want you to do this. No solution. Don't do any freaking work. Well, let me just show you what happens if you start to do the work. So what happens if you square both sides? So here, this is wrong, but let me just do it. If you square both sides, these cancel. You get 5x minus 1 equals 4. It's going to work. What the shit? 5x equals 5. X equals 1. Right? You just said there's no answer. You got an answer. Yeah, I got an answer, but if I check it, doesn't work. Ain't no freaking way. Why did I get an answer that doesn't work? What's wrong with you, Mac? You're hard enough already, and then I'm doing shit that's wrong? Because when I squared both sides, I lost the fact that that's negative. So the math goes, this has an answer, but it's not the answer for this, because that's got a negative there. Right? If you plug a 1 in, what do you get? 5 times 1 is 5, minus 1 is 4. Square root of 4 is not -2. So this is what's called an extraneous solution. I'd hope to God, though, that if you saw this, you would just do no work. Say no solution. And don't make every other problem no solution. There's a problem. So here's a problem that is not no solution. There's one major difference between what I just wrote and every other problem we've done so far. And what's in the wrong place? That -5 shouldn't be there. I need to isolate the radical element and then kill it. Right? So this is where math class becomes tyrant class. This is how you run a country. You isolate the radical element and then you kill it. Throw the bombs in there. Anybody else got something to say? No? All right. So that radical's not by itself. Yeah, you add 5. So do you see how you might say there's no solution because you go, it's negative. No, it ain't. If you add 5, you get 3. That's fine. Nothing wrong with that. Finish that out. X is 2/3. Check it. 3 times 2/3 is 2. 3's cancel. Plus 7 is 9. Square root of 9 is 3. Minus 5 is -2. Check. I really want you to understand. This is nothing new about solving equations. This is nothing new about solving equations. The only new thing is there's a radical in there. Now we know how to handle those. Solving equations never changes. The idea.
This chapter's way better.
This section?
I like this section better than
This
last.
section is the best.
That's cool. I like
I
that.
like this way more.
I normally don't hear that.
No comparison to the last section.
Yeah, for sure.
That's because we haven't done. Here we go. Just trying to let you enjoy it for a minute, but
It's a trap.
man, it's a trap. All right.
So this is one that we would see on the homework right now?
And these are also you'll see on the homework, and then these are
Okay.
you'll see on the homework.
Advanced.
Now, you'll see quickly why this one is a little bit different. Once I figure out something that'll work nice. Okay, I got it. I think I got it. Yes. Okay. What is majorly different here now from everything we've done so far? There's another variable in here. That doesn't do anything to my first step, though. Is the radical by itself?
Yes.
Yes. So then how do I kill it?
Square it.
Square it. There's an x that's stuck in a square root, meaning I can't get my x's together. I can't do anything. So, of course, that's my first priority is free that dude, right? So I square both sides. The big mistake I see is somebody just says that's x squared plus 4 or something. That's insane. How do you square x minus 2?
X minus 2 times x minus 2.
You write it twice. Don't lose the middle term. So you get x squared minus 4x plus 4. When you FOIL that out, is that cool? So the first steps didn't care about the fact that there's an x over there. I care because now how the shit do I solve this?
One side is 0.
Good. Get one side equal to 0. Doesn't that feel familiar?
Yes.
Yes. Maybe. So minus 2x plus 1, minus 2x plus 1. So both of those cancel. I get 0 equals x squared minus 6x plus 5. And then, of course, what do I do with this? Factor. So 0 equals there's only one way to factor 5. And they both have to be negative so that comes up positive, that comes up negative. Right? So x is 5 or 1. Now I gotta check to see if I got any extraneous solutions. So let me just plug this shit back in. But notice this. At this point, do I know what kind of number x minus 2 is? Bless you. Do you know what kind of number x minus 2 is? Is it positive or negative? X minus 2. I have no idea. No, you don't know. If x is 5,
Then it's positive.
that's positive 3. It's fine.
But if it's
If x is 1,
It's a negative.
that would be negative 1. There would be no solution for that, right? So obviously, when I plug these in, 5 should work, 1 shouldn't. So when I plug these in, let's see, if I plug 5 in, 10 minus 1 is 9. Is that equal to 5 minus 2? Is everybody cool with that? I just put a 5 in. I'm checking 5. 10 minus 1, 9. 5 minus 2 is 3. That's true. What happens when I put a 1 in? I get the square root of 2 minus 1 is 1. Is that equal to 1 minus 2?
No.
No. So you cross that out and you circle that. Don't just not write the 1 because then I need to see it actually showing up and you saying no. You must check the answers to a radical equation because there could be answers that are extraneous, that are not really there. It's not Matt's fault. We did something that lost information about whether this is negative or positive. That's why there's answers that might not work in the original. Yes?
So, going back to like the top, so you do x minus 2 and x minus 2, but how come you do that instead of, and when you do other problems, it's x minus 2 and then x plus 2?
All right.
Like, what's the difference? Like, why?
This says there are 2 of these. That's it. It can't suddenly become plus because it wants to. I've got 2 of these. So what do I write? One of them and another one of them. I don't have one of these and something else. Does that make sense? I said this earlier. People make that a plus for some reason, but it's 2 of these. X minus 2, x minus 2.
And when would you make it a plus?
If you're factoring x squared minus 4, yeah, then that's x plus 2 minus x minus 2, of course.
Okay.
But if I have anything squared, that thing is going to show up twice. There's no other choice. You can't just make 1 plus because that makes it easier or something. I like it. That's where most people make their mistake, is this here. All right. So here, you guys try this one. Let's see. You can do it, Jeff. Can you? I don't know anymore. Yes, okay. You can. Oh shit! Why are you doing this to yourself? about? That should work. Should work. Now, real quick, just in case anyone's doing this, why would I definitely not want to square both sides right now?
Because there's a 1.
If I squared both sides right now, I have to square both sides. I can't just go, I'm going to square this and this. No. And then what would I have to do with this? I'd have to FOIL it. And then the middle term would still have a radical. So not only would I make a lot of weird shit, I wouldn't kill my radical. That's why the first step is get the radical by itself. So the first step should be what? Add 1. Beautiful. Just to stop you in case you're not doing that. Get some weird shit. Bless you. Done with it. Bless you. I was done before you wrote it down. I was gonna wait. So if I square both sides here, I'll do that side. Whew. Let me get over here. Yeah, so you get x squared plus 2x plus 1. I like this problem. This is where people kind of freak out about how to factor this correctly. Now I want to get it equal to 0. But when I do that, what happens to the 1? Goes away, and then people do this all kinds of weird-ass ways. What's the first thing you try? Is GCF. It will save your ass from doing weird-ass things. What comes out of both? X. So what are my two answers? X is
0.
0.
2.
2. Do both of them work? If X is 0, I get square root of 1 minus 1 is 0. Is that true?
Yes.
Yes. If I try x equal 2, I'll get square root of 8 plus 1 square root of 9 minus 1 is 2. Is that true? C. So they both work. So you don't always end up throwing something away. That's why you got to check. You don't just take a guess and go, I'll throw this one away and maybe I'll be right. No, you just check. Don't check them here. Don't check them here. Check them in the original. Yes?
And what does the 2 work? Because 9 minus 1 is
Yeah.
8.
9 plus 1. I'm sorry. 8 plus 1 is 9.
3.
Square root of 9 is 3. Minus 1 is 2.
Okay.
All right, so one last problem, and then we'll do a review. Here's the ultimate ugly problem with these things. So every problem we've done so far, how many radicals were in it?
1.
Every problem we've done is one radical in it. So how many times did it have to square? Once. Makes sense. If there's one radical, I square once, it should die. You should know where I'm going.
Oh, yes.
So what if there were 2 radicals? Let's see, 3 minus x plus the square root of. I should probably have an answer in mind. That would work better, Jeff. All right. Right. Okay. Yeah. Oh shit! So you still sort of start off the same way. You isolate one radical, square both sides, so you kill that radical. The other side is going to be what people kind of give up on without even trying. So which radical, it doesn't really matter. I'm going to subtract this over there. Get this radical by itself.
Wait, what?
I'm going to isolate one of the radicals. So I subtracted that over there. Not a big deal. Still, pick a radical, isolate it. And then what do? Same step I did before. What do?
Square?
Square both sides. I'll do this side. Whew. Now this side, just to be safe, you write this sucker twice. And this is where people go, well, I'm going to not do that problem because I'm not even going to try that shit because it's got to be hard because it looks hard, and that's bullshit. Foiling is foiling. Doesn't matter what's in there. Just start, what's 4 times 4? Oh my God. And what's 4 times this thing? Negative 4 times this thing. And what's 4 times that same thing again? Negative 4 times that thing. And what's negative times negative? Positive. Square root of this times square root of this
9.
is this. No. What's the square root of 11.7 times the square root of 11.7? 11.7. You see why I was trying to get you ready? What's the square root of this shit times the square root of the same shit? Is that shit. It's 3 minus x. Please understand that. That's what I kept doing there. Square root of 22 times the square root of 22 is 22. Does everybody get that? So the square root of this thing times the square root of the same thing is that thing.
Yeah.
Bam! It makes that so much easier. Don't foil this shit out on the inside and you make yourself go insane. If you're still not really liking that, what's the square root of 3 minus x times the square root of 3 minus x? Isn't the square root of 3 minus x squared? Right? Don't these kill each other and then you get that? Okay. You do that too, if you really want to. Oh my God. Now, you see what I said earlier. How many radicals were there to begin with? 2. I'm going to have to expect to eventually have to square twice. So pretend like this is the problem from the beginning. I try to get my radical by itself and then square both sides. So I'm kind of starting over now. Let's get all my like terms together stuff. What do I get over here? 16 plus 3 minus 8 of these bad boys minus x. Is that cool? Getting my like terms, the numbers, the radical 3 minus x is. Poor little minus x all by himself. Which term has a radical in it? This one. So let me move everything else on the other side. Isolate the radical part. So we add x, subtract 19. So we get 4x minus 16. Now before I square, can you see a number I can divide nicely? 4. 4 goes into everybody without making any fractions. Did I see that? Now you could square both sides and work with the bigger numbers, but anytime I can divide by something, make all the numbers smaller. Yeah. How do we feel so far, though? I mean, isolate one of the radicals, which means you're going to have an ugly thing to foil. You're still going to have another radical. But now look, how many radicals are in this equation? 1. There were 2. That's a much better equation then. There's only one square root when there were two before. So let me isolate that stupid thing and kill it. All right? Let me bring it up here. So if I divide everything by 4, divide by 4, divide by 4, divide by 4, I get x minus 4 equals negative 2 square root of 3 minus x. So I made my numbers as small as I can. So now what do I do to both sides?
Square.
Square, to kill that last radical. Or you guys like this one? This is the hardest kind of problem like this. Okay? So if I square both sides, over here I'll get x squared minus 8x plus 16. Right? If I write it twice, FOIL it out. And over here I get, what's negative 2 squared? 4. And what's square root of 3 minus x squared? 3 minus x. I like it.
Why did you square it?
Why did I square here?
Oh,
To get rid of the radical. So why did I square there? To get rid of the radical. How many times did I square? Twice, because I had 2 radicals. So now this is going to be 12 minus 4x. And now I can move this stuff over, get it equal to 0. Same idea as before, right? I got an x squared term, I got to get it equal to 0 so I can factor. Same stuff. Well, that's neato. How do I factor this?
X minus 2.
Yeah. So what's the one answer? And does it work? 3 minus 2 is 1. The square root of 1 is 1. 3 times 2 is 6 plus 3 is 9. The square root of 9 is 3. Is 1 plus 3 equal to 4? Yes. Okay. Let me give you this here. This is the answer key for that practice test. Right next to you. Cool. So just remind you guys, if you haven't tried the practice test out at all, don't even look at this. So, like I said before, you do it and you agree with me, you develop false confidence, and somebody says, well, false confidence is better than no confidence. No, it's like if it weren't for bad luck, I'd have no luck at all that whole time. So yeah, don't even look at this if you didn't try it. It's not going to help you out at all. Trust me. So now I'm going to open it up, wide open to whatever you guys want to focus on. We can do more of what we just did. We can go back and do something from earlier. Remember, this is from 8:3 to 10:6. That homework is due tomorrow. Shit. All right. So what you need to do is, if you are very behind, you need to do a few out of every section to get ready for the test tomorrow. Turn in something, don't turn it in later, whatever, right? You go, whatever you got to do to me, Jeff, I just got to get ready for the freaking test. Yes? Okay. So what, anybody have something we want to focus on? Yes?
I have a question. Why don't you both of them like two?
From the very beginning? Why don't I just put a square next to each?
Yeah.
Okay, because I'm not allowed to. Because how's it go? If you do something to one side, you have to do it to the other side. So I can't square parts of a side. Right? In fact, watch. This is the part that I don't think you guys see enough of. If I make an equation that's true, that's just numbers. Now watch. if I square both sides, let me do something really strange, like this. And then I'm going to FOIL this because I'm going to just pretend like I don't know what 1 plus 3 is. So if I put 1 plus 3, 1 plus 3, and this is 16, right?
Yeah.
So let's see, 1 plus 3 plus 3 plus 9, is that 16? Yes. 10 plus 6 is 16. That checks. Now watch, if I try to start with the same equation and just square each piece, is 1 plus 9 equal to 16? No, it's not true because you didn't do the same thing to both sides. You did something to parts. That's not allowed. Because it doesn't maintain the equality unless you do the same thing to the entire side. So I don't have that option to just square each separately, right? And the student will be like, why would I do that? Because I would get rid of both the radicals. That would be awesome. But it don't work. It doesn't make things true. So no, I can't do that. Is that cool?
Yeah.
Yeah, I wish I could. Trust me, I'm a math geek. That'd be amazing if everything was set up so I could do that. I wouldn't have to, look, this is a long-ass problem. You guys got to here and like, screw this problem. Okay. Shit, that's just one problem. I'm not going to do that problem. I can live with those points. All right, whatever, shit. But it'd be so much better. It'd be so much quicker. But you get to the wrong answer real quick. So don't do that. Yes? Oh, good. All right. So I left that first one. I wanted to do that together. For one thing, I was lazy. I didn't want to get another sheet of paper and do it on there. But for another thing, I want to be able to do it live in front of you so you can really see what's going on. That's that first problem on the practice test. I put the by hand without a matrix down there, but I said in class for the matrix version. What would that matrix look like for number 1? So 1B. What's that matrix look like?
1, 2,
1,
4. -2.
negative 2,
4, 8.
4, 8. I like it. And then I'll just get the rest. You guys got it. Negative 2, 1, 1, negative 4, and then 6, negative 3, 1, 5. And then double check. 1, negative 2, 4, 8. Negative 2, 1, 1, negative 4. 5, 1, negative 3, 6. Okay. Because it's already hard enough. If you start with the wrong problem, well, this is some weird shit. So at least double check to make sure you wrote it down. Now again, I'm still being really, really nice here on this problem because what's really nice about this problem? There's a 1 there already. So how can I use that 1 to start getting closer to my goal? What's my goal, by the way?
1, 0, 0, 0, 0, 1, 0, 0, 0, 1.
With a bunch of numbers there. Okay, so I can start. It doesn't really matter which column you start with. To be totally honest, that's one level of flexibility I want you to realize. So I could start with this column and use that one to kill those. Doesn't really matter. But let's just do this. What would I do to kill this? So if I do twice row 1, add it to row 2, put the answer where? Row 2. Row 2. Okay. So if I double this row, it'd be 2, negative 4, at 16. So let's see. So this row is going to become 2 minus 2, like we wanted. Negative 4 and 1. 8 and 1. 16 minus 4. 20. Now, let's see if you guys can handle it. I don't want to write this matrix a lot. I'm done with these, right? How do I kill the 5? I'm going to do what?
-5.
Negative 5 row 1 plus row 3. Put the answer in row 3 because that's where I want the 0 to show up that I'm going to make. I want the 0 to be here. So if I multiply row 1 by negative 5, it would be negative 5, 10, negative 20, negative 40. So that's what it would be if I multiply it by negative 5. So negative 5 and 5 is 0 like I want. 10 and 1, 11. negative 23. Negative 40 and 6 is negative 34. 1, negative 2, 4, 8. So the first row just stays the same after all that. Do you notice something I can do with this row? Yeah, and divided by what now? Divided by negative 3, because that'll make a 1 here, which is what another part of my goal. That's really nice. So if I divide row 2 by, yeah, there, 3, negative 3, I'll get 0, 1, negative 3, negative 4. Is that cool? Let me go ahead and rewrite everything. What the hell? All right, that kicks so much ass because I can now use that 1 to do what? Multiply by 2, kill him. Multiply by negative 11, kill him. Right? If that wasn't a 1, I showed you a way to make a 1. Or if you don't want to do that, you can just multiply 2 rows by something to make a 0. Because zeros are the most important thing in this process. 1s are just nice because they make it easy to make zeros. So what do I do here to kill the 2? Yeah, take row 2 times 2, add it to row 1, put the answer in row 1. That's where I want the 0 to show up. I'll lock it. Let's make you sure. So if I multiply this one by 2, this would be 0, 2, negative 6, negative 8. So if I add these together, I get 1. See how that 0 doesn't screw with that 1? I get 0, negative 6 and 4, negative 2, negative 8 and 8, 0. That just happens. Who cares? I'm done with this. Go away. How else can I use the 1 again? I can do what now? Yeah, multiply this row by negative 11 so I can kill that 11. Again, because I want a 0 here also, right? So if I do negative 11 row 2 plus row 3, put the answer where? Row 3, that's where I want the 0. So this would be, if I do negative 11 times row 2, I get negative, I get 0, negative 11, 33, 44. So I get 0 and 0 is 0. Negative 11 and 11 is 0. 33 minus 23 is 10. 44 minus 34 is 10. That kicks ass. And negative 0, 1, negative 3, negative 4. Okay. So use the 1 to make zeros. Move to the next column. Use the 1 to make zeros. Move to the next column. And if there is no 1, you can still make zeros. That's the important thing. Good. And I can divide row 3 by 10 to make them 1s. Is that? This is dividing row 3 by 10. Now I can use that 1 to do what? Kill that, and then I can use that 1 to kill that. And why is that last row like the most powerful row? It's got 2 zeros that won't screw with those. So if I multiply, what did we just say? If I multiply this row by 3, it'll kill that. So if I do 3, 3, 0 and 0 is 0, 0 and 1 is 1, 3 and negative 3 is 0, 3 and negative 4 is negative 1. Now if I multiply that row by 2, it'll kill that. 0, 1 is 1. 0, 0 is 0. 2 and negative 2 is 0. 2 and 0 is 2. Bless you. So what's the answer?
X equals 1.
No.
X equals
Oh,
X equals 2.
Y equals negative 1 and Z is Z.
Z equals 1. Which is the same answer you get, hopefully, if you do it without a matrix. So again, the main idea is to make zeros. Ones make it easy to make zeros. Because if there's a 1 and there's a negative 88 there, I'm going to multiply by 88. That's awesome. If I don't have a 1, I might have to multiply both rows by something to make a 0 there, but zeros are the main thing to make. Where do I want 0 to show up? Well, just know what your goal looks like. You know what to do. Okay.
Can we do 5C?
Oh, what was the thing about domains and what kind of root it was? So, you know, if I have the square root of x plus 2, how do I figure out the domain of that? No.
Zero must be
The inside
greater than.
must be at least 0.
Oh.
Oh, that don't square anything. I just look at the inside. The inside has to be at least 0. So x has to be at least negative 2. What if it was the cube root of x plus 2? What's the domain? All real numbers. Because the cube root has no problems. So now we get to 5c. Almost. Let me ask you this question. What if it was this? What if it was 1 over x plus 2? What's the domain? Say in English what can't happen. What can't happen? The bottom
Can't be 0.
can't be 0. So the bottom can't be 0. If I solve it, x cannot be negative 2. So this, in English, the inside has to be at least 0. That's what I write. Here, the bottom can't be 0. That's what I write. And then I solve it.
I just forget why, like, how did you be able to tell all real numbers in there?
If it was an odd root where there's no problem on the inside.
Okay.
The odd root has no problems. The only possible problem would be the function on the inside, and that's 5c. Right? 5c says 7th root of 2 over x minus 6. Does the 7th root have any problems?
No.
No. But the inside function has a problem where? In the denominator, x can't be 6. So the domain of this is x can't be 6. Not because of him, because of him. Yeah. So that's the one time for an odd root, the domain won't be all real numbers, is if the thing on the inside has a problem somewhere. I gotta throw that number out.
So you're not sure for that?
No, no.
Only when the root is even.
If the root's even,
That's what you do.
there's a level of problem right there. Yeah.
Okay.
This guy, there's no problem here, there's a problem there.
Okay.
Yeah. This will just be the rest of the class.
For 9B. Oh, never mind. I switched there.
I was excited for a second. So yeah, number 7 is from the section 8.3, right? And then number 6 is from the stuff we just did, section 10.6. Is that the same problem? No, it's a little different. Okay. Yes.
How many problems with approximately are going to be able to test?
Same length as the first one, roughly.
So we have about 3 hours to do the test.
2.5. Always, at most 2.5. Else, any more than that, I go insane. Or more insane. I designed it to take less than 2 hours, but I give you more just in case you're like checking and double checking everything, not knowing what the hell to do on something and trying everything.
And the last one
Yes.
It's off topic, what was that for?
It's one of the original book covers for the book, War of the Worlds. If you never read it, if you only ever saw the Tom Cruise movie, which was good, you should read the book. It's sense. See the original movie before computers and all that shit came out. They did some shit. Or don't do any of that. I don't know. Let me do whatever you want to. It's from a company called Out of Print. They do like book covers on t-shirts. It's kind of neat. That's where I got the iRobot one. Yes.
In 9.2, are they gonna be adding the word problems?
9.2?
Yeah. On page 660.
Yeah. I can never do put one on here. No. But there definitely will be a word problem on the test. Yeah.
Can you do number 5?
The one about the triangle?
Yeah.
I think I might have actually done all of it. Let's see. So they give you the variables already, right? What's the first relationship that they put down there? They say the measure of angle B is 3 times that of A. So the measure of angle B is, what's that in math? Is equals, the measure of angle B is 3 times that of A. Well, how would you write that? 3A, all right. Take yes. What's the second thing they said?
Angle C is 20 degrees more than...
So C is 20 more than A.
20 plus...
Sure, 20 plus A or A plus 20, either way. And then there's a third equation. That's just the fact that it's a triangle. What are all the angles add up to be in any triangle? 180. So A plus B plus C is 180. So notice this B is 3A. So can't I put a 3A there? Because B is 3A. And C is A plus 20. And then I got an equation I can solve for A. Once I know A, I know B, and I know C.
I got stuck because I didn't think of the 180.
Oh, yeah, shit. That's the one that's always in the background for triangles and angles. You always got that relationship right there. Yes?
18 on 9.3. It's a weird matrix.
Oh, yeah. All right.
What number?
18 and 9.3. So what's it got? It's got 4908, right? 4A, 9B, 0C, 8. 8 and 6C, so no B's. 8, 0, 6, negative 1. And then 6, 6, no A's, negative 1. Yeah. Gruesome. So the sucky thing about this matrix is, well, yeah, one thing is there's no ones. But also, do you see how it's basically impossible to not lose a 0 to get somewhere? Whatever you do, you're going to lose a 0. Do you see that? This is a lesson about doing column, column, column. If you don't, like somebody kind of started this matrix and got this far, they did a shitty job because they kind of did something and then they went to the next column and then they went to the next column. I'm like, ah, shit, I'm going to have to lose a 0 because you did this stuff out of order. So this ain't your fault. It's just the way it is. You're going to have to lose a 0. So between these two, could I make a 0 here? If I multiply this by negative 2 and add it, but I'm going to lose that 0, but oh well. Do you guys understand? A little bit? So here you're going to have to lose a 0 because somebody did this matrix and didn't do it in order. That's why I tell you do the first column and then do the second column, because if you start bouncing around wherever you see you can make a zero, you're going to probably have to lose some of those zeros just to keep going. So I pick a column. You can even pick this column because these would kill each other pretty nice, wouldn't they? It doesn't matter which column you pick. All right, so I don't know which column you want to pick. We'll do a couple first steps. Which column you want to work with? The first one? Okay. So if I multiply this by -2, cool? It's going to kill this guy. All right. I'm then going to write all this stuff down. -8 and 8, 0, and then I get -18, and then I get 6, and then I get -17. And this is still 4, 9, 0, 8, 0, 6, 6, -1. And then I move to the next column. Now, why might I want to move to this column next? Because it's already got a 0 here, right? Let me stop. You see how I lost a 0, didn't I? I lost that 0 there. But this is better now. If I move to this column, why would I want to move to this column necessarily? Because it's already got a 0 here, right? I don't want to have to lose another 0. So now I can just make a 0 between these two. How do I make a 0 between these two? Multiply one of them by -1. Where do I want that 0 to go? Yeah, so if I multiply, multiply the third row by negative, I like 0, -6, -6, 1. And I add those together, I get 0, -24, 0, -16, yeah, I like it. And then I get 4, 9, 0, 8, 0, 6, 6, 3.